Welcome to a new video. In this video, we are going to build a data science project. This video will have data analysis, feature engineering, and machine learning parts. I'm going to use a Kaggle dataset and I'm going to leave its link in the description of this video. You can easily download from there and run the codes with me. The dataset is about data scientist salaries and we can directly start. We are going to start by importing the libraries we are going to use. We are going to import pandas. We are going to import matplotlib, .pyplot, splt, and we will import seaborn as SNS. These are enough for starting, and after that we are going to load our dataset. I will use data frame is going to be equal to the pd read csv, and we will say data science salaries.csv. Also, we can just write df and see if it's loaded successfully, and it seems like it is. So let's say data frame.head and see the first 5 rows. Also, you can specify this number. If you write 3, you can see 3. If you write 4, you can see 4 rows. So let's talk about our data set. So at the first column we have work year, it has dates here. In the second we have experience level, we have like senior, mid, we have employment type, contract, full-time, we have job title, principal data scientist, machine learning engineer, salary integers, salary currency, euro, USD, salary in USD, it's our reference currency, I guess, and we have employee residence, remote ratio, like if it's 100, I think it's fully remote, and if it's 0, it's on-site. We can see the company location and company size. I think company size classification based on the employee count, and dataset seems great. We are going to try to predict this salary here. So we can code this as a regression problem. Great. So let's get an overview of the dataset using dataframe.info. And from this dataframe.info, we can see the memory usage, data types count, and nominal value count. So let's get the numerical summaries of the numerical columns. Like here it is. We can see the average salary, average work year, but it's I think meaningless. Like it's like 2022, which means most of the data in the dataset starts with 2023, I guess, but it's not another really meaningful thing. Like we can just use work year that value counts, and it will be better for that column. It's not that good with date type of values, and we can see the salary in USD and remote ratio. So from this remote ratio mean, we can see that people are more likely to, or companies are more likely to work their employees on site. Like they are working on site more than the remote because this is less than 50. So great, let's keep going. Let's check for the NA values. Is NA, like if you run this like this, you are going to see you will get booleans in the values. If you do sum, you will get column wise NA values, and we don't have any in our dataset. So let's also check for the duplicated rows. We have that sum and we have duplicated rows. So what we can do is we can just do data frame drop duplicates if you want to, and if you run like this, it's not going to change the original data frame, and you will see it's going to be still in here. So what you can do is you can just use data frame equals to, or I more use this, I prefer this one, I use in place equals to true instead of it, and I'm going to run this, and you will see we don't have any in the original data frame right now. If you want to modify the original data frame, don't forget to use in place or reset the df. Let's check the relationship between experience level and salary. So I will do sns.boxplot, and we will say x is going to be equal to the experience level and y is going to be equal to the salary, and we will set the data as data frame we have, and let's give the title like salary distribution across experience levels, and we will use plt.show at the end. And here it is. So we have an outlier in here, and what we can see from here is some mid-level entries taking more than the others, and I think it's not that meaningful, so we can just skip this grab and we can check this relationship in other ways in the group bys. And what we can do is, let's check another thing. We will say data frame group by. We are going to group by employment type and calculate the average salary based on. So we will say employment type and I will say salary, and we will use dot mean after that. And here, so we can easily manipulate this, like if you say head after this and two, it's a pandas series, it will display the first two. You can say tail and it will display the last two. So what I'm going to do is rerun this and I will say sort values and I will say ascending equals to false for seeing the maximum at the first. So after that we will see that employment type freelance earning the most and employment type part-time is earning the least. Great, so it can be expected like this. So what we can do right now is, let's say job title counts and we will say data frame job title value counts. Let's get the value counts of the job title and let's just check how does it look. Great, so let's do like sort values and we will say in place equals to true because I want to modify the original data frame, and I will say, let's say ascending equals to false. I can't use all of them if I want to do a visualization, so I'm just going to take the big values like the first five, like I will say like these are the top five and I'm going to create a bar plot with them. So what I'm going to do is I will say job title counts dot head. After that I will say plot and I will set the kind as bar. Then I will say title and I will say job title distribution. I will say X label is going to be job title. Also I want to fix this typo here, and then I will say Y label is going to be count and I will use plt.show at the end. Great. By the way, I take the first five values, but if you want to take the bottom five you can just use tail and you will get the lowest values. Also what you can do is you can just say head and you can say 3 for having 3 bars in this graph like this. Great. So let's do some group bys and explore our data set. I will say let's group our data by work year and calculate the average salary for each year. So what we can do is I will say average salary by year. I'm just going to show you the variable assignment. I won't do that again. I will directly write the group by data frame group by work year and I will say salary and I will use dot mean after that. And we can just call this like average salary by year and here it is. So let's get the maximum, like we already know this. Sort values ascending false. So who is the winning one? 2021. Great. I think it's related to the monetary policy on the pandemic and okay, great. So let's do another group by. We are going to group by employee residence and calculate the median salary for each country. So I'm not going to assign it to a variable like average salary by year. I will directly write data frame group by. Since we are working in an IPyMB notebook, we can directly run without assignments or print statements employee residence salary and we will use median. And here it is. Great. So let's also say sort values and ascending false. So we can see our information right now. Great. Okay, let's do a final quick group by. Let's group our data by company location and find the maximum remote ratio for each country. So what we can do is we can say data frame group by company location and we will say remote ratio. I'm trying to use as much as methods as I can so you can see the most and its ratio. Here it is. So some countries don't have any remote workers and some have. So what we can do is, for seeing the non-remote workers ascending, actually it's sort values ascending, this time true, and we will get the zeros in here. Great. So what we can do is, let's say mean instead of this, and we'll get the mean remote ratios for each country, like let's say, not say ascending and sort and type of that, because if we do that we will only see zeros and hundreds. And great. So the threshold is 50. Also 50 means that hybrid, actually if we see an entry with 50, we can just say it to a hybrid work, like 2 days office, 3 days remote, or something like that. But if the value in here is less than 50, it means that the employees on that country more likely to work on site, and if it's greater than 50, then they are more likely to work remote. Okay, let's create a bar chart of the average salary for each experience level. So we will firstly do a group by, then we will use dot plot. We can do it in the same line, or we can assign a variable. I will start by assigning a variable, and after that I'm not going to do that. So let's say average salary by experience, and we will say data frame group by, and we are going to group by experience level. Then we will say salary, and we will use dot mean. So we set this. Then what we are going to do is, we will say average salary by experience dot plot, and we are going to say kind is going to be equal to the bar, and let's set the color as sky blue. I like this color type of the chart, and we will say plt.title, and we will say average salary by, actually not by, across experience levels, and we can say for the X label experience level, and for the Y label we can say average salary, and we will use plt.show at the end, and here it is. So we can also get this in sorted way, like we can just say sort values and ascending equals to false. And now we are going to see it's going to be sorted like this, and we've seen this in the box plot. Mid levels are getting the most. Actually, I think it's because we took the mean, because there was an outlier. I think you can remember. I'm not sure if that can affect that much. So we can just check median instead of mean, and let's see. Yeah, expert, senior, mid. Okay, now it's true. Expert, senior, mid, entry level. So the outlier was affecting this graph. So looking the median instead of mean can cover you from affecting from the outliers. Median is a better metric on this type of things, I guess. Great, let's create a line chart of the trends in remote ratio over work year. So what we are going to do is, I'm not going to assign a variable. I will say data frame group by work year, and I'm going to take the values of remote ratio, and I will say that mean. Then I'm going to say that plot, and I'm going to set the kind as line, and I'm also going to add markers like this, and I'm going to set the color as green, and I will add title like this, trend in remote work ratio over the years, and I will say X label is going to be work year, Y label is going to be average remote work ratio, and I will use plt.show at the end, and here it is. So we can see after the pandemic the remote ratio is really dropped. It started with 65s, and at the peak of the COVID it's around 70, and now it's around 40. So we can see a decreasing remote ratio trend. Also, I can observe it in the job market. Great. Let's create a scatter plot of salary against company size. So I will say scatter. Also, I'm trying to cover the most of the graphs. And if you want to learn most of the plot types, you can just check my Plotly course. I'm covering most of them. Oh, I also have courses for Matplotlib and Seaborn in my channel. You can check them from the channel playlists. We will say data frame company size, and after that we will say data frame salary, and let's set the alpha as 0.5 and color as, let's use orange this time. And I will say title salary versus company size, and I will set X label like company size and Y label as salary, and I will use plt.show at the end of this, and here it is. So there's an outlier in the large one, and also we can see that large company pays much more. You can observe from here, and the least paying one is the small company. Great, so let's group our data by job title and plot a horizontal bar chart of the average salary for each job title. But as you know, it's not possible since we have a lot of job titles, so I'm just going to take the first 5 again. I will say data frame group by, and we are going to group by job title. Then we will take the values of salary, and I will use that mean. Then I will say sort values, and ascending is going to be equal to the false. And then I will say head. Then I will say plot. Actually, it's a lot. Mean, sort values, head, plot. And I'm going to set the kind as bar, but we are going to create a horizontal bar chart, so I add H in here. And let's set the color as purple this time. And let me show you, go over this once more. We are grouping by job title, taking the values of mean salaries. Then we are sorting the values in the descending order. Then we are taking the first 5. Then we are using dot plot. We set the kind as horizontal bar chart, and we set the color as purple. Great. So we will save title, and let's give it a title like average salary by job title, and let's add X label like average salary and Y label like job title, and we will use plt.show at the end of this, and here it is. So the most is head of machine learning, and we have principal data architect, lead machine learning engineer, lead data scientist, data analytics lead. Also, we can see the least earning ones like product data scientist, staff data analyst, and it goes like this. Great, so let's just use head again and keep going. Okay, so what we can do is let's just create 2 more graph, and let's go on the modeling side after that. So we are going to group our data by employment type and plot a pie chart of the distribution of employment types. So I will say data frame employment type actually, and I will say value count, and after that I will say plot, and I'm going to set the kind as pie, and I will set auto PCT, and you are going to remember this by using again and again. And after that, let's set the colors like, let's actually use different colors, like we have gold, we have light coral, and we have light sky blue. And I'm going to show you without this, and after that I'm going to add that, and you're going to see the difference. And I will set title like distribution of employment types, and I will use plt.show at the end of this. Actually, we got an error, employee type. Let's see why this error occurred. Okay, it's employment type. And now it's going to work smoothly, and here it is. So there's some problems with this. As you can see, we don't want a Y label in here. So what you can do is we can just say plt.y label, and we can just add an empty string in here, and here it is. It looks better. Actually, it's full-time mostly, and we can just add auto PCT, the thing we deleted, and we are going to see the percentages right now with this. Like here it is. So 98% of the data we have has the employment type of full-time. Wow. Okay, let's do a final plot and get on the feature engineering side. So let's group by company location, and plot a bar chart of the median remote ratio for each company location. So I will use head again, but let's use head 15, something like that this time. So I will say data frame group by, and we are going to group by company, location, and we will take the remote ratio dot median, and I will say head, and let's take 15, and I will say plot kind equals to bar, and color is going to be equal to the, let's say, teal, and we will say title like median remote work ratio by company location, and we will say X label is going to be company location, and by label as median remote work ratio, and we will say plt.show. Great. Also, again, you can easily sort this, like I think from here you can say sort values ascending false, and after that you will get the biggest values, and here it is. Great. So since this is median, it's going to take 100 or 50. If you change this to mean, you will see that it's going to be a more meaningful graph, and here it is. So great. So let's do feature engineering right now. We will call data frame again, and we are going to pick some variables from here for the modeling. So I will call data frame columns, and after that we are going to work on this, like let's set the X, like we can take employment, I'm not sure, not job type. We are also going to take the Y, like data frame, and we will take the salary for the Y. It's a sure thing, and let me think a second and I will start the record again. So we can take experience level for sure. We can take actually employment type, and what we can take else is we can take company location, I guess. We can take company size, and we can take, actually I'm not sure. Okay, let's also take employee residence, and we are good to go. So our X is not that good actually. We don't have any numeric values right now, and we are going to try to build a model from this. Okay, so here what we can do is we need to change these columns into numeric ones, like the Y is numeric, Y is okay, but every column in here needs to be changed. So what I'm going to do is I will use label encoder, like I'm going to import from sklearn import preprocessing, and this senior is going to be like 0, mid is going to be like 1, and by changing like this you can train models. In this type of data you can't train because there's no numeric values and we need numeric values, so we will do encoding. So I will say label encoder, I'm going to initialize this like preprocessing label encoder, and after that we will say X, and let's also do like this. We would use label encoder fit transform, and we will say X column name. I'm just going to copy this, and we have 5 columns, so I will do it that 5 times. And now what I'm going to do is I will just do copy pastes for making this operation faster. I'm going to do copy paste for that, again for this, for the company size, and for the employee residence. Okay, now I'm going to fix this actually from here, and great. So I'm just going to run this, and now what I'm going to do is I will call X, and you will see the difference right now. They are all numeric. Actually, these are a little bit nonsense, but I didn't have anything to select, so it's a hard data set to model. It was better for a data analysis project, I think, but we are good to go. We can go like this. So what we need to do is we need to do scaling because it ranges really differently in here. We have a lot of different countries. So what we are going to do is firstly we will use train test split on our data. Like, let me quickly talk about this. We are going to split our data as train and test, and we are going to train our models on the training set and test our model's performance by the test set. We are going to have 4 different variables: xtrain, xtest, ytrain, and ytest. We are going to train the model with xtrain and ytrain, and then we are going to make predictions with the xtest, and we are going to compare the predictions with the ytest, which are the actual values. So by that we are going to get metrics like mean squared error, etc., and we can compare the model performances by that. So how we can do that is for the train test split we will say model selection import train test split, and then we will say xtrain, xtest, ytrain, and ytest. Then we will say train test split, and we will say x, y, and test size is going to be equal to 0.2, which means the 20% of the data is going to be in the test set and the 80% is going to be on the training set. So here it is. Great. So now we are going to use scalar. So I will say from scalar.preprocessing import standard scalar, and I will say scalar, I will initialize this like standard scalar, and then I will say scaled xtrain is going to be scalar.fit transform xtrain, and scaled x, actually let's use this kind of letters, test is going to be scalar fit transform and xtest. Great. So great, everything is okay, and we can go to the modeling side right now. So let's start by defining a function which will return us the model results, and we don't need to call like mean squared error again and again. So let's import numpy, and let's import from sklearn.matrix import mean absolute error and mean squared error. And then what we are going to do is we are going to define a function like model results, and we will say predictions inside of this, and we will say print mean absolute error on model is, and I will use that format after that, and I will say mean absolute error, not squared, absolute error, and I will give the ytest and the predictions which we will be passing in this function. Like these are going to be the values which will came from the model, and also predictions actually, and also let's print something like root mean squared error on model is, actually let's delete this firstly and use this kind of letter, and then I will say format again. I will this time use numpy the square root because we are going to get the root mean squared error as our matrix. So I will say mean squared error ytest and predictions, and everything seems great. So we can just run that and start to work on our models. I'm planning to train 3 models. It can be linear regression for the first, and we can check others. Like I'm just going to say from sklearn.linear model import linear regression, and I will say linear regression and initialize this. Then I'm going to fit this model into my model like using the scaled xtrain and ytrain, and after that fitting this and training our model, I will do predictions with this like linear regression.predict, and I will use scaled xtest, and you can see the predictions in here. I'm going to just use predictions linear regression as variable and store them inside of it, and at the last step I will say model results, and I will pass predictions we made into our function, and we can get the mean absolute error and root mean squared error. How good is this model is depends on your expectations as the values of correctness and also the data, but these values are not going to be so good because we are not using any numeric thing in the modeling side. We are just using like the encoded variables, but I'm going to try my best and I will train different models to reach the best score. But these models can also be usable if these values are good for your specific problem. So great, let's keep on going. So for the other two models, I will use something like grid search, which will help us on the parameter tuning. The models have parameters and you can optimize them for getting better performance. And let's train a support vector machines model and we will do parameter tuning on that. Model selection, import, grid search cross-validation, and we will import support vector machines, import support vector regressor. So after that, I'm going to say SVR model is going to be equal to the SVR, and we are going to define parameters grid SVR, and we will say C can take values like 0.1 and 0.5. You can add different values if you want for trying out other things. And kernel is going to be, it can be linear, RBF, also it can be polynomial, but I'm not going to add that. And let's add a degree like, let's say 3 and 5. Great. So let's initialize this like grid search cross-validation, and we will say SVR model, and we will give the parameters we created, and we will use grid SVR.fit, and we will use scaled X train and Y train. So what we do in here is we are searching through these parameters and checking for the model performance and trying to find the best performing model, and here it is. So after this, let's say print best parameters for the model is, and we can use format, and we can say grid svr.best parameters, and in this way we can see that C is 0.1, degree is 3, kernel is RBF. You can extend these values, like you can add 0.05, or you can add 1, or you can, at this side you can add polynomial, and you can add more degrees. Great. So what we are going to do is we will say predictions grid SVR is going to be grid SVR.predict, and we will use scaled X test, and we will get the model results like predictions grid SVR, and here it is. So it's a degrees. By comparing the linear regression, we improved it. Great. So let's train a final model and end this video. And I'm going to select from the models I know. Let's go with a tree-based model, and let's do random forest. So we will say from sklearn.ensemble, I will import random forest regressor. So for the tree-based models, you don't actually need to scale your data. You can directly use xtrain and xtest instead of scaled xtrain and xtest. But I'm going to use the scaled versions. There's no problem in that, but you don't need to. You can just remember that. It can be asked in interviews, or there can be situations where you need to use this information. So I will start by initializing this, like I will say RFR model is going to be equal to the random forest regressor, and then we are going to define parameters grid RFR, and I will say actually we need to open a dictionary, and we can set max depth. It can take values like 5, 10, 15. I'm not going to add 10, and it can take maximum features like auto and this, and for the number of estimators side, it's also a parameter. We are going to add, let's say 2, 5, 8 and 10. Great. So these are enough. Again, you can extend these values for getting better performance. It's not a sure thing, but you can try more things if you extend these values. And I will say grid RFR is going to be equal to the grid search cross-validation RFR model and parameters grid RFR. And after that, we will use grid RFR.fit, and we will use scale. Actually, again, you don't need to use the scaled values, but I will use like this by train. And let's train our model. Actually, there's a problem. Let me quickly check. It's number of estimators. It's a misspelling on there. So estimators. So this time it's going to run smoothly, I guess. And here it is. Great. So let's say print best parameters for the model is, and we will use format grid RFR dot best parameters, and we are going to make predictions with that. So preds grid RFR dot predict scaled x test, and we will get the model results from this, like predictions grid RFR, and here they are. So I think support vector model performed better. Yeah, it does. So in this case I would go with the support vector model, but this can depend, and also you can try other models, like you can try decision tree, AdaBoost, ridge regression, K-neighbors regressor, XGBoost regressor, and much more. That was all for the project. Thanks a lot for watching my video. I'm creating content about data science and programming. You can subscribe to my channel for more. I have a playlist of projects where I have more than 25 data science projects. You can check them from the channel playlists. I'm also going to add its link at the end of this video. You can also go from there. Thanks for watching again, and have a great day.